All right. Okay, so we're going to talk about new topics from today. It's about loops. Okay, about loops. So far we talked about if statements, and there are many interesting logical operators that we talked about already. But now for loops, things will get even more interesting, especially we talk about array, which I will start hopefully on Wednesday. And let's just talk about the motivation for loops and also learning outcomes. Today is going to be light. We'll just focus more on the syntax on the loops. Okay, the learning outcomes for today, for the whole lecture. So for loops, think about why we really need loops. It's really for repetition of similar actions, which you did already in your lab number 2. But we'll give you more sophisticated exercises to do in the later labs. And then there are 2 common loops we can use. One is called for loop, the other one is a while loop. So these 2 loops are interchangeable. So they are really equivalent to each other. So you don't really have to choose one or the other. But there are certain common scenarios where you want to use one, but not the other. But we'll see. Okay, and then we have, especially when we go to later on for this particular lecture, we're going to see about nesting loops, especially if you have, remember in the if statements, we got nested if statements. In the case of loops, we can also get nested loops. So these are the interesting cases you can solve more interesting problems. Okay? Now, let's just go on to the motivation very quickly. Whenever you want to have similar actions for repeating, for example, recall what you did for Lab 0 Part 2, the grade report program. You got 10 assignments to really enter the grades. Also, you got 10 quizzes to enter the grades. Now, how can you actually solve that using a loop? Because every time you want to read the integer from the user, you don't really have to say it 10 times. You can simply use a loop for doing that. Okay? So this is like a very common scenario to use loops. Okay, for example, you can print the hello world message for 100 times. You don't necessarily want to print out, write a system out the print line for 100 times. That's not the way to go. You can simply write a loop starting from 0, starting from 1 until 100. That's how you can do. Okay, and this second problem over here is more interesting, the problem we're going to focus on later. How do you find a maximum value in a list of numbers? So this is something you want to really get used to as well once we talk about array. Guys, should I really throw someone out from the classroom? People at the back? Listen, you're wasting everybody's time. Mohammed, could you please look at who's talking? If it gets loud again, I will throw somebody out. I don't want to do this every time, all right? Okay, so now we're going to talk about this kind of maximum value in a list of numbers later on in the course, once we talk about array. And you also want to repeat similar actions under certain circumstances. So this is something a little bit more abstract, as we'll see more example. For example, let me give you some. Let's say you keep letting the user enter new input values for calculating the BMI until they say quit. If the user didn't say quits, you got to keep allowing them to really enter the input. So this is what we did for lab number 2. So this is the more common scenario for using a while loop. So again, as a recap over here, so when do you have to use loops? There are 2 scenarios over here. Number 1, you can either say for a specified number of times. Let's say I want to print out hello world for 100 times. This is one scenario. The second scenario is while certain conditions true, let's say the user keeps entering something does not quit. I'm going to actually let the user keep interacting with the program. That's just another scenario. So you can see I explicitly use the for a while. So these are the 2 scenarios you want to use a loop. That's something you want to get used to as we go through the examples. Okay, so as I said, today is going to be light. I'll just talk about syntax first, and then these are interesting exercises to really understand better how the for loop and while loop work. That's kind of the idea. Okay, so now let's talk about the first example over here. Okay, so now you can see the syntax here, and which you also did in the tutorial. Remember, for the for loop, this is a keyword you have to write, and then there are three parts over here. One part is called the initialization, initial action, which is executed only once. And then we got something over here. This is so-called stay condition, which means as long as this condition is true, we're going to stay in the loop. Okay? And then we also got another increment over here. This is typically just I++, but it doesn't have to be. We'll see example where it is not I++. Okay? This is simply just updates. Updates at the end of the iteration, at the end. Okay? You can see we got continuation condition, and also we got the body of the loop. So this part over here, whatever you put inside the brackets for the loop. So this is a bracket for the loop. And this part here is called the body of the loop. Okay, so these are the terminology we mentioned already in the tutorial video. So now, let's see, and also this action over here, I++, is going to be executed at the end of each iteration. Okay, that's kind of the flow chart I talked about already. Okay, so now, let's talk about this particular loop specifically, and we want to work out some important questions. Okay, again, we got integer I, which is the loop counter, is initialized to be 0. As long as I is less than 100, I'm going to stay in the loop and execute the body of the loop. And then at the end of each iteration, I'm going to say I++. I'm hoping that eventually I can really make the state condition here false, eventually. So it's really important to say that eventually should be false. If your state condition ever becomes false, that simply means you got an infinite loop. Your loop never exit. That's really important to keep in mind. Okay, so now, given this particular loop, we want to think about the following two questions. Number one, how many times is this particular condition checked over here? So let me just highlight again. So this is the condition over here we want to check. We say as long as it is true, we're going to stay in the loop. As soon as it becomes false, we're going to exit from the loop. So now, for this particular loop, how many times are we going to check this particular condition? How many times? 100? 101? 99? That's a very important question to answer, but we'll try to help you with that. And number two, how many times is this particular body of the loop going to be executed for this particular loop? You can see that over here. We want to first of all work out exactly how many times the state condition will be checked, how many times it will be true, and how many times it will be false. And then you want to work out exactly how many times the body of the loop will be executed. So these are the two important questions for you to answer. Okay, let's work it out together. Okay? Let's now go to basically the same block of code over here, and then let's try to see how we can answer that. I'm just choose to use a table here to help you. Okay, it's not that complicated. Okay, let's just go over it all together. Again, let's have a look. You really want to observe the pattern of change on the value for loop counter I. I is initially 0, and then we know that I is going to be incremented by 1 every time. So that means for i's value over here, as I try to draw in the table, starting from 0, and then it can increment to 1, increment to 2, and all the way to some values, right? However, we want to see that exactly when this state condition over here is going to be evaluated true and false, right? We know that this is going to be true. If that is true, that tells us stay in the loop. And we know that if it is false, it's going to exit from the loop. Okay, so these are the two principles over here. But now we want to see exactly how many times. Let's see here. Let me just highlight it. So now you can see in the very first time, when I is simply initialized to be 0, that means 0 less than 100 is going to give me true. That's for the very first time, right? And when I is incremented to 1, 1 less than 100 is still going to give me true. So that's the second time, right? And then it's going to be incremented to 2, and then 2 less than 100 is also going to be true. You can see so far we have done 3 iterations for the loop, and all of them are going to make the state condition over here true. Okay, so far so good. So now we want to see what is going to be the last value that is going to make this state condition true. The last value making this state condition true is going to be the last iteration to execute for this particular loop. So what will be the last value over here? Okay, you can see that over here. That's why you really want to be sensitive to the state condition over here. When I say I less than 100 over here, we know that I starting from 0 all the way to 99 is going to make this particular inequality true. And as soon as I becomes 100 over here, so 100 less than 100 is going to be the first time it's going to become false, right? That's kind of the pattern for the loop counter. Okay? So now if you look at the table over here, you can see that, so we keep incrementing I until the very last time when I is incremented to 99. So we got 99 less than 100. This is still going to be true. So that means we go for the last iteration. Okay, that's the last iteration we make. So now how many times have we executed the body of the loop? You can see that over here. Starting from 0 and then until I is 99. For every such number, we try to execute the body of the loop once. So from 0, basically you think talking about this particular interval here from 0 until 99. How many numbers do we have in this interval? From 1 to 99, you got 99 numbers. Now we also got 0. So you got 100. Okay? So 100 times that we try to execute the body of the loop. Okay? That's the answer for question number 2. How many times is the print line, the body of the loop, is going to be executed? In this case, it is going to be 100. 100 correspond to exactly those loop counter value that is going to make the state condition true. And then after the very last iteration, we're going to increment from 99 to 100. As soon as we increment to 100, now you can see 100 less than 100 is going to give you false. So this is last check we do. So which means we got exactly one more time we have to check than the number of times we got to execute the body of the loop. Okay? So now over here, so this, go back to here, how many times is the state condition going to be checked? It's going to be exactly 100 times. Oh, sorry, 101. That's what I meant. Okay, let's write it down here. So it's going to be 101 times. Okay, now if you want to split it into 2 parts over here, it's really important. The very first 100 times is simply just going to be true. And the 101st time, the last time, is going to be false. So true and false. It's a very important insight into the for loop. Let me just recap very quickly, okay? And then I'll see if you got any questions. Whenever we talk about the for loop, you want to pay attention to the initial value for the loop counter, and also the state condition over here for the loop, and also how you increment the loop counter every time. So now the 2 important questions is, how many times are you going to execute the state condition in the loop? And also how many times you're going to execute the body of the loop? And the way you can figure that out is to have some table like this, and then to see how many times the state condition is going to be evaluated to true, and also the last time is going to be evaluated to false, exactly one more time. Okay? Any question about this? Okay? This is something we didn't really talk about in the tutorial video. That's why I will emphasize this over here. Okay? Okay, after this, let's talk about something also simple here. There's some alternative syntax you can write for the for loop. As we said before, let's say again we talk about this particular for loop. We say that this is only going to be executed once. Once only. And also this particular update statements over here is going to be executed at the end of the iteration. Okay, so these are the 2, the first and third part that we just talked about. Now how we can rewrite the loop in a way that's going to be equivalent. Let me show it to you. What you can do is, since this is only going to be executed once, so I can simply put it here at the front. I can say integer I is assigned to 0. Okay, I just put it outside the loop. And then I can write a for loop over here, for, and then I simply leave this part empty, and then put a semicolon here. And then I still put a state condition over here, I less than 100, and then semicolon. And then for this particular part, I'm just going to move it to the end of the iteration. Let's see exactly how we can do that. Okay, let me just put down the body of the loop over here, which is print line. And then whatever welcome to Java over here. And then we can now put this particular updates over here to the end of the iteration. So I can say I plus plus. Okay, this is equivalence. Okay, this one is more common over here, but this one also works, if that makes more sense to you. Okay, either way it works. Okay, okay, so that's about the for loop. Again, this tracing using a table is really important for you to get insight into the for loop. We're going to use a similar style for tracing when we get to the similar problem later, more complicated problem. Okay, so that's what we just talked about rewriting the for loop. And let's do some exercise over here. Okay, I want you to look at the program over here. The first one, we say that the loop count is called count rather than I. You can name that whatever variable name you like. Let's say integer count is initialized to be 0, count is less than 100, and count plus plus. As we learned from the previous example, how many times will the body of the loop be executed? It should be 100, okay? If you're still struggling, you should really review the part I just talked about. Now, let's have a look at the second program over here. The second program, as I said, the initial value doesn't have to be 0 always. Now I start a count to be 1. And then the state condition here is count less than 201. And then the update part, I don't necessarily have to put count plus plus every time. I simply say count plus equal 2. Okay? And then I simply just, again, the body of the loop looks the same. Welcome to Java for both of them. Now the question for you, are these two programs going to produce the same output at the runtime? That's the question. The key to solving this problem over here is as follows. Because we know that the body of the loop over here, the body of the loop is simply print out welcome to Java for the first one, and also welcome to Java for the second one. So now they will be the same if they run the same number of iterations. Agree? So now we want to know, for example, we know already the first one is going to print out welcome to Java 100 times. But what about the second one? Is it also going to print out welcome to Java for 100 times as well? That's the question. Okay? So this is something I would like to show you, like a little bit analysis over here. You want to, again, observe the pattern for the loop counter and see how it changes from the initial value until the very last value that's going to make the state condition false. So now, let's move on to iPad and try to figure that out. Okay? So these are the two programs over here. So let's just see the first one, okay, to give you some idea. We want to look at the first one and the second one. The first one over here, we know that the count starts with the initial value being 0. 0 over here, we know that 0 less than 100 is going to be true. Okay? And that is the very first iteration we're going to run, right? When count is equal to 0, we're going to execute the body of the loop for the very first time. That is why for iteration over here, I simply put 1. Okay, let's do one more. When count is incremented, at the end of the first iteration, it's going to be incremented from 0 to 1. And then 1 less than 100 is going to also give me true. And then that's going to be iteration number 2. Okay, so far so good. And if we keep going like this, what's going to be the last value of count that is going to make count less than 100 still true? 99. If I put 99 over here, you can see 99 less than 100 is still going to be true. And now, which iteration would it be? Let me put a question mark here just for now. And then, after this, our count will be incremented again. In that case, it will become 100. In this case, 100 less than 100 will become false. So we don't go for any more iteration anymore. So now the question is, what should this question mark be? Which iteration should it be? You want to really see the pattern over here. You can see the relationship between iteration number, which is 1, 2, 3, 4, etc. The count is 0, 1, etc., right? It's exactly the count value plus 1. In this case, that should be 99 plus 1, so which would be 100. So we got 100 iterations. Okay, this is only just a warm-up for you to observe the pattern for the loop counter. Now we want to do something similar to this for the version number 2. Okay, so we can figure out exactly if version 1 and version 2, they are equivalents for their runtime. Okay, so now let's have a look at the second one over here. Count, the initial value is going to be 1. So starting from 1 over here, and then let's try to see 1 less than 201 is going to be true. Okay, and then we're going to enter the first iteration. Okay, the first one is not that easy for you to see the pattern yet. What about when count is equal to 2? Actually, you can see that the way we increment the count at the end of the iteration is count is assigned to count plus 2. That means the next count value is not going to be 2 anymore. It's going to be 3. Okay, can you see it? Okay, the most important part for you to see is the way we update the count in the second version of the loop. We simply say count plus equal 2. So that means when count is equal to 1, from 1 to 3 is count plus equal 2. Okay, so now let's see this. Now 3 less than 201 is going to be true. And this is going to be iteration number 2. Agree? Are we okay so far? The difference is for this second version over here, count is incremented by 2 at the end of each loop. And the state condition over here is also different. It's simply less than 201. Any questions? Yes, exactly. So you can think about every time for any for loop, you're basically having some interval over here. But here, in this case, you can see the interval for the count is simply from 0 until 99. Okay, right? For the left-hand side. The right-hand side, the interval is not exactly. You want to numerate the interval. But we'll see once we finish the table. Okay. Yeah, the way you figure out exactly what the interval looks like is by looking at the initial value for count and also how the count is incremented every time, right? For this particular one, it's incremented by 2 every time. Let's do one more. And then from 1 to 3 and then 3 to 5, right? It's incremented by 2. Now 5 less than 201 is also true. And this is the third iteration, okay? If we go along like this pattern over here, what's going to be the last value for count that is going to make the state condition still true? Remember, this is strictly less than. So if count increments up to 201, it's not going to make it true. So it should be 201 minus 2, which would be 199, right? So now if I put 199 over here, and then 199 less than 201 is going to be true. Okay? Which iteration should this be? I'll put a question mark here just for now. Okay? And now, as you can see, after that, as soon as you increment to 201, and then you check this particular state condition again, 201 less than 201 is just going to be false. So we don't go into the loop anymore. So now, how exactly can we figure out this question mark over here? That's the question. Basically, you can see that we want to calculate exactly from 1, 3, 5, all the way to 199. We want to see what's the size for this particular interval. That's what we want to figure out, right? But how many are there? Okay? Let me show you one way to do it. All you have to do is to see what's the relation between the iteration and the count value over here. You want to see between these two guys, okay? Can you come up with any formula over here? I want to say something like this. The value for the count is equal to the value for the iteration. I simply call it I, right? You can see between 1 and 1, 3 and 2, 5 and 3, and also 199 to something, right? Can you see the relation here? So count would be, what about I propose one? What about count is exactly equal to 2 multiplied by I minus 1. Okay, let's see this. Let's try to see if this formula will work. In a case where count is equal to 1, we know that I is just equal to 1, right? 2 times 1 minus 1 will just give me 1. That will work. Oops, you cannot see that, right? Let me just maybe make the formula a bit down. The formula I just wrote is count is exactly equal to 2 times I, minus 1. Okay, that's the formula. Let's verify this formula together. For row number 1, you got count being 1 and I being 1. So count is 1 and I is 1. So 2 times 1 minus 1 will just give you 1, no problem. What about second row? You got 3 and 2. 3 over here, and 2 times 2 minus 1 will also give you that number, right? So the key really is to figure out this formula over here. That's really the key. I'm just showing you one example. Okay? Again, why are we doing this? The very purpose for doing this is because we are given 2 for loops. They got different initial value. They got different state condition over here. They also got different updates. But we want to answer the following question. Are they going to generate the same output at the runtime? So this is how we figure that out. Because we know that the loop body over here looks identical. So it boils down into how many times are we going to print out the loop body. If they print out the loop body for the same number of times, then they should be the same. So that is why we're trying to figure out using these 2 tables over here. For this particular one, in the second one, it's a little bit more complicated. The way to figure that out is to enumerate the count and the iteration number and see what's the relation between them. Okay? And eventually, what we get is we got this particular formula. Count is simply equal to 2 times I minus 1. Okay? That's the formula. Okay? So now, given this formula over here, what should be the question mark over here? Well, let's try. We know that let me see this. So count is 2 times I minus 1. And now we talk about count is simply 199. So that should be 2 times 100 minus 1, right? So it should be 100. Okay, so that's how exactly you can see the number of iteration over here is from 1 to 2 all the way to 100. This one is also the same. 1 to 2 and then to 3 all the way to 100. So now this is how we prove the 2 programs are equivalent at the runtime because the body of loop is simply just identical. And the number of iterations for both versions will just be 100. Okay? Any questions? I think for you, maybe what you will be struggling with is this table here. Try to really review that. Okay? That's the critical part. To figure out this formula here. Okay? That's really important. Okay, so now, given this, let me modify these 2 versions slightly and ask you the same question. Okay? Okay, so that's exactly what you just said in the iPad. So now let's have a look at basically the same program over here. Okay, let's have a look at these 2. Similar. Let's say we have this one here. Count is initialized to be 0 and all the way up to 99, right? 100 wouldn't actually be included. So now we want to know exactly how many times are we going to print out the body of the loop. In this case, 100 times, right? What about the second version? The second version, you can see the initial value is 1 rather than 100. It is 1 rather than 0. And the state condition over here is less than or equal to 100 as opposed to less than 100. So now we want to figure out if these 2 loops will give you the same output at runtime. Okay? So let's see over here. Okay? Again, so these are the 2 programs. Let me highlight the difference syntactically. You can see over here, initial value is 0 versus 1. And also the state condition is less than 100 versus less than or equal to 100. And also the updates is count plus plus versus count plus plus. Okay, so these are the three things for the two for loops. Are they going to produce the same output at the runtime? First of all, how many iterations do we have? How many times are we going to execute the body of the loop over here and also the body of the loop over here? So now, just to give you a little bit of hints over here, you can figure that out by using the same table as we just did. Okay? For this particular loop, we start with 0 and all the way to 99. And for this one, we start with 1 and go all the way to 100. Okay? You can see the size of this particular interval is 100, from 0 to 99. And the size for this interval here is also 100. So it seems like the body of the loop for both versions will be executed 100 times exactly. But now, does that really mean they're going to be the same output to the console? If you look at the body of the loop more closely over here, it says in the outer print line, welcome to Java, and welcome to Java over here. However, if you look at the loop counter over here, that's also part of the loop body. If you look at that, count is included and also count is included. So now, that's a hint to you. Now, even though both programs are going to execute exactly 100 iterations, are they going to generate the same output to the console? No, right? Let's see exactly why. For the first one, what we have is something like this. For the first one, we have welcome to Java, and then the first count value is simply 0. And then also welcome to Java, and then 1, and welcome to Java, also 2, all the way to 99. Okay, that's the console output for the first program. What about the second one? That hopefully you see the hints over here. The second one is start with the initial value 1. So that means the first line of output is going to be welcome to Java, and then 1. And then welcome to Java, and then 2, all the way to welcome to Java, and then 100. You can see the output is not the same to the console, even though they are executed 100 times for the loop body. Okay? So again, the lesson we learned really is, in the case where the body of the loop are simply just identical, in that case, you have to figure out exactly the number of iterations for your loop. Okay? That's the first example. The second example over there, even though some loops got exactly the same number of iterations, but you want to look at exactly what's going to be executed for each of the iteration. In this case, it turns out they are not the same. Okay? You can see from 1, 2, 1 to 100, here from 0, 1, up to 99. So they are not the same. Okay, any questions about this? Okay, so after this, let's look at something else. Okay, let's do some exercise over here. Okay, so now we're going to figure out what's the output for each one of them. This one should be easy. Okay, so this one here, we got initial value is 1, less than or equal to 5, and then I plus plus. You simply want to print out the value for I. Okay, how many iterations do we have in this case? 5, right? Okay, in that case, hopefully you'll be able to see the very first value that's going to be printed out is 1. Okay, just 1. So that's what you will have. 1, 2, 3, 4, 5. This one's easy. What about the second program over here? Second program is simply just a simple rewriting of the first one. We have this particular initialization, and then we have this particular increment over here at the end. So as we said before, they are completely equivalent. Oh, okay. So now for this program over here, we simply have this program here. Initial value is simply just 1, and then it's less than or equal to 5, and then we simply got I plus plus. Okay, and then it should be just equivalent to the first one, right? It's just simple rewriting. Okay. Okay. What we have is simply 1, 2, 3, 4, 5. Okay. The first two are easy. What about the third one? What will be the output for the third one? I'll let you think about it. I can tell you the critical thing to look at is really this line here. You can see in this particular second version, I++ was placed at the end of the iteration. But now I++ is placed in the beginning of the iteration. Okay? So now, is the output going to be the same or different? Okay, so now let's try this. Okay? So now let's do a very quick table over here. The value for I, and also I less than or equal to 5. Okay, and then after I++, and then after I++, we're going to print out the value for I. Okay, that's exactly what we're doing for this version here. Let's try. Okay, initial value for I is simply just 1. 1 less than or equal to 5 is simply just true. That means we have to go ahead for the very first iteration and then do the I++. I++ is going to be true, right? It's even before we print out for the very first time. And then we try to execute this line here, print out I. So that means the very first value we print out is simply just 2 rather than 1. Okay? And then after this, we're going to go ahead. So now I is now the value 2. And now we're going to check the state condition again. So 2 less than or equal to 5 is just going to be true again. And then before we try to print out the statement here, we do I++ first. So that means I++ will give you 3. So you print out 3, and so on. Okay? So now, what will be the last value to be printed out? 6, okay? Anybody? Okay? Let's try this. Now, what I will do is, what about when we get to 5? When we get to 5 over here, 5 less than or equal to 5 is going to be true, right? In that case, we're going to increment 5 into 6. So that means we got 6, and then we print out simply 6. But is 6 really the last output? Let's see. If 6 is simply the last value over here, so we simply put 6 here, 6 less than or equal to 5 is going to give you false. That means we don't go ahead with the loop body anymore. Okay? So that is why for this particular loop, this is what you have. 2, 3, 4, 5, 6. Okay? So now you really want to make yourself flexible. Basically, what I'm trying to show you over here is, whenever you put I++ as a third part of the loop for loop header, it is as if you put I++ at the end of the iteration. However, you do have another option here. You can simply leave this third part empty, and then you can choose to put I++ in the beginning of the for loop. It's completely up to you. Okay? I'm just trying to show you the 3 different ways of writing loop. In all the 3 versions, you execute the body of the loop exactly 5 times. However, the third one is going to give you different outputs simply because you do the I++ first before you try to do anything with it. Okay? So that's exercise number 3. Okay, let's go on to the while loop. The idea about while loop is completely symmetrical to the for loop, so I wouldn't bother you too much, but I'll just highlight the important things to you. Okay? So now for the while loop, one thing to note, the while loop has only one part to specify. So this is the state condition. Okay, that's the state condition. In the case of the for loop, you have to put one part over here, semicolon, one part over here. But for while loop, you simply just put only one over here. Okay, syntactically, that's the difference. Okay, now we ask you the same questions over here. How many times are we going to check this state condition over here? The idea is really the same. I'll just show you the table very quickly. Okay, and also how many times are we going to execute the body of the loop over here? Right? So these are the 2. Okay? See, these are the 2 questions. The same conclusion, let me just tell you what the conclusion is. If you think about the number of times we're going to execute this particular state condition is x, and then you think about the number of times we're going to execute the body of the loop over here as y. You have x is exactly equal to y plus 1. Okay? What is the plus 1 over here? The 1 over here is exactly when the state condition evaluated to false. Okay? The same idea as before for the for loop. evaluate to false. Okay, the same idea. So now let's look at some example over here. Let me just highlight to you the same table over here really. So what I will try to see over here is, you can see initial value for loop counter j is simply just 3. And then we say less than 103, okay, strictly less than. And also we have j++ at the end of the loop. Okay, that's what we have. So now, starting from j is equal to 3, in which case the state condition 3 less than 103 would just be true. Okay, that's the first iteration, right? And now you can see that j versus the iteration over here, what's the relationship between them, right? Exactly j minus 2 will be the iteration number. Okay, the same formula, similar formula as I derived previously. Okay, that's something you can also get used to. And now you can see when it is 4, it's also going to be true. Now, what's going to be the last value that's going to make the state condition over here false? It's going to make it true. Because it is strictly less than. So the last value to make it true will be 102. So this is last value over here that's going to make it true. As soon as we increment 102 to 103 over here, this is going to make it false, right? Exactly one more time. So how many times do we execute this? The body of the loop is going to be 3, 4, 5, all the way to 102. Okay? So now, we want to know what's the size from 3 up to 102. Okay? To calculate the size of the interval, you can simply do the end minus the beginning plus 1. Okay? That's something you learned before. Okay? It's simply just 100. And the last time is simply just going to be the false evaluation. Okay? The number of iterations. Okay, that's about while loop. Similar idea. And now, over here, the same idea over here. Let me just briefly mention, I wouldn't do the table again. I will leave that as an exercise for you. You can see the initial value here is 0 versus 1. And also, the state condition is strictly less than 100 versus less than or equal to 100. And also the update part is count plus plus versus count plus plus. And then you can see that the body of the loop is simply equivalence. Welcome to Java and welcome to Java. They're the same, right? So now the question is, are they going to be equivalents at the runtime? Since the body of the for loop is simply the same, are they going to be executed the same number of times? Okay, it turns out they will be the same. Okay, let me just sketch the solution for you. This one here is going to be starting from 0 all the way to the last value that is going to make the state condition true will be 99. Okay, this one's easy because you simply have count plus plus. And what about the second program over here? The initial value is just going to be 1, and then all the way up to and including 100. So that'll be the last value to make it true. So from 1 to 100. Okay, so now that means 100 times. And also this is also 100 times. Okay, so they are equivalents. Okay. So now let's see over here. Just want to talk a little bit more about while loop. Again, this table here is really important for you to trace the behavior for the loop. Okay. Okay, so last exercise over here. Similar idea over here. You can see basically the same loop. So we got 0 versus 1, and also we have strictly less than 100 versus less than or equal to 100, and also we got count plus plus versus count plus plus. Now, are they equivalents at the runtime? What you have to see is about the loop body. In the previous example, the body of the for loop, the body of the while loop are simply the same. They are the same in the previous case. But what about in this case? You can see we are trying to use count over here. Okay? So now if you see the output, what's going to be the first output for the while loop? It's going to be welcome to Java and then starting with 0. What about the first output for this second program over here? is going to be welcome to Java, and then it's going to be 1. You can see just from the first line is already different. So that's different. Okay? Again, you should really pay attention to the loop body as well to see if they're identical. Okay, so now let's do a little bit more exercise over here. We still got 5 minutes. A very quick slide just on the primitive statements and compound statements. So we talk about basically a statement is simply a block of code in your Java code. And we got primitive versus compound. Primitive simply means they're simple ones. And the only primitive statements we have is just a single assignments, which we have done a lot. And compound statements, we have already covered if statements and also the for loop and while loop. So these are so-called compound statements. Towards the end of the lecture, for this particular for loop, we're going to see exactly how we can nest if statements inside for loop and also for loop inside while loop and so on. So these are the different combinations of program you have to get used to writing. Okay, so let's see one exercise over here. So now what we want to do is, let's consider this program over here. So this program here, we simply prompt the user for a radius value. Let's say it's a double. And then we simply read in the double from the user radius, but we don't actually check to see if the radius is positive or not. And then we simply calculate the area from the user, given the radius from the user. And then we simply print out what the area is. Well, as we learned previously, this is not good, because what if the radius is negative? In which case, we simply wouldn't have a chance to really output the error to the user. So what we want to do is the following. Let's say we want to extend this program over here so that we're going to repeatedly prompt the user for a radius value as long as it's positive. As soon as the user actually gives us a negative value, we're going to stop the program because there's an error. Let's say that's what we want to do. Okay, so how do we do that? I will show you the code very quickly. This is something we did in the tutorial video. Okay, let's do that very quickly. The only extension I made was we have a while loop over here. So this is a very typical scenario for while loop. We want to say as long as the radius read in from the user is larger than or equal to 0, we're going to keep calculating the area for them. As soon as they give us anything that's negative, we're going to stop and give them some error message over here. Okay, you can see this is the scope for the while loop. Okay, so line number 1, line number 2, line number 3, line number 4. So these are the body of the for loop, the while loop. Okay, let's just give you some feel about how this can be executed quickly. Okay, let's trace this program quickly, and then we'll continue next time. Okay, just give me one or 2 minutes. Test number 1. What if the radius is simply -3? If the radius is simply -3, that means -3 will be stored over here. So now -3 larger than or equal to 0 is going to be false. That means we bypass. We don't even go for the while loop for the first time. And then we're simply going to execute error negative radius value, right? That's a test number 1. What about test number 2? Let's say we enter 2, okay? So now, for the first time, we simply enter 2 over here. So that means 2 will be stored as a radius. So now, when we go and check the while loop, 2 larger than or equal to 0 is going to give us true. That means we're going to execute this particular while loop for the very first time and calculate its area, right? So now you can see that we're going to prompt the user for just another radius value. Let's say this time the user gives us -3. So now let's say they give us over here -3 over here, and then radius is going to be -3. So what's going to happen? So now we are reaching the end of the while loop. So now we'll go back to check the while loop header again. So now the radius value is now -3, right? That's the second input from the user. So now we get -3 larger than or equal to 0 is going to give us false. That means for that one, we're going to have error negative value for the radius, right? So now, say that very quickly. For this particular one, what we're going to have is something like this on the console. You can see for the very first value for 2, we're going to tell you what the area is. Area is whatever it is for radius 2. And then as soon as after we enter -3 again, it's going to output error negative radius value. error, negative radius value. Okay, so make sure you understand these two test cases. Hopefully you already picked them up from the tutorial video. Okay, I'll stop here and then I'll continue from Wednesday.